All right. Here's the quick lead-in, guys. What we're studying here is something called Metathesis reactions. Okay. Metathesis reactions right up there. Okay. Metathesis. Okay. Turns out that metathesis reactions, there's 3 different kinds. We're going to focus on only one of these kinds. I do need you guys to know that there's 3 kinds for the test and know kind of the definition here of them. But otherwise, we're not going to do much with the neutralization of the gas production reactions. So we're going to discuss what happens when we take silver nitrate aqueous and we add it to sodium chloride aqueous. We're going to take 2 solutions and put them together. This already predicts the products for us, right? It says we're making solid silver chloride and aqueous sodium nitrate. So one of those things is still a solution. The other one is a precipitate. It's a solid. So we would have to rewrite that in a manner that looks like this. All right. So molecular equation here, guys. By the way, this is what's known as a molecular equation. I don't know why they call it a molecular equation because technically these are formula units, right? But they're just trying to show that they're stuck together. Okay. Technically speaking, this doesn't give us all the information that we want, the molecular equation. Turns out we can write something a little bit different called a complete ionic equation, which you're going to have to be able to write. It's a CIE. Okay. In a complete ionic equation, the definition is this. You take all of the strong electrolytes, so the strong acids, the strong bases, and the soluble ionic salts, the things that are listed as soluble on the solubility rules, and you dissociate them from each other and just rewrite the reaction showing them dissociated from each other. Okay. So one question that was just asked that is a good one. Why is that silver chloride on the right side of the equation over here, why is it that it's still solid? It's simply because it's an insoluble compound. And I know that because it said that it was a precipitate. I could look it up on the solubility rules, though. Finally, guys, we have to write what's called a net ionic equation. A net ionic equation is going to tell us exactly what's happening chemically in this reaction. So the nuts and bolts, let's get rid of all of the superfluous stuff. Let's get rid of all the extra stuff that's just confusing the situation. And let's look at what really is happening chemically. What bonds are being formed. Okay, so in order to do that, what we have to do is identify the spectator ions. Spectator ions are ions that are just spectate. Just like in a football game, they do absolutely nothing to help the results of the game or the chemical reaction. The remainder, whatever remains after we've crossed things out, is going to be the net ionic reaction. So we have to write one more reaction. We're just basically copying the things we didn't X out. The net ionic equation. But this is the net ionic reaction. Ag plus Cl yields AgCl. If you're wondering why, that's because we crossed out the spectator ions, the nitrate, and the sodium. Okay. So steps to writing a net ionic equation are to write the balanced molecular equation, then dissociate all the strong electrolytes, which basically gives me the complete ionic equation. Then I cross out anything that remains unchanged from the left side to the right side because those guys are spectators. The final step is to write whatever is left over and call that my net ionic equation.